Hello everyone. We are now on the section 3 of chapter 4, the chapter on inequalities. These problems here are the same thing we've been doing. The only difference between these problems and the previous sections is that there are more steps to do, more adding, more multiplying, more subtracting, more dividing. That's it. As you can see by this example, we had to combine these two terms. Then we had to add them over to this side, and then we had to divide them by 3. And this should have been n is greater than or equal to 6 there. And so we're going to do the same thing here. We're just going to do more of the arithmetic. Here we multiply the parentheses, as you could see, take away 6, and then we are now to divide by 12, and that's where you get n is greater than or equal to 2. Same thing here. We want to keep our variable on the left. That's the first thing we need to do. First, we combine terms. 5 minus 2 is 3n plus 3 less than n minus 9. Our first objective always is to get all the letters or variables on one side. And so I have to move over the n, and you get 2n plus 3. Then we take away 3, we take away 3. We get 2n is less than or equal to negative 12. Remember, you are adding negatives, not multiplying, and that's why it stays negative. And the last step is divide by 2, because the opposite of multiplying is divide. The final answer you are going to get is negative 6, and that's it. All of these problems are the same thing. They're only a little bit longer than the others. We multiply, we get 6k. We multiply, we get plus 12 minus 5 less than or equal to 4k minus 1. Combine like terms, and you're going to get 7 there, and we are here. And then we subtract 4k, and we subtract 4k. And then we get 2k plus 7 less than or equal to negative 1. It's almost like an equation if you think about it. What you do to one side, you do to the other. Take away 7. You get 2k is less than or equal to negative 8. Divide by 2 and divide by 2. And the direction stays the same because you divided by a positive number. Moving on over here, we have more of the same. We have a fraction this time. So I'm going to take 2/3 times 6 over 1 first over here. And you'll notice you got 12 over 3, that's 4. So this is going to be 4y. I want to take 2/3 times 12 over 1. And you're going to get 24 over 3, that's going to be 8. Minus 8. And then plus 4 is greater than 10. Then I do the combining of terms. That's 4y minus 4. And then we add 4. Then we add 4. And then it gets down to 14. And then divide by 4. And we reduce by 4, rather. Reduce to lowest term, so you're going to get y is greater than 7 over 2. Always reduce your fraction. Here we have a decimal. We are going to multiply the decimals. 0.5 times 8. You're going to get 4 or 4k. And then 0.5 times 5. You're going to get 2.5 plus 2.5. And then 2k minus 1.5. Don't forget, we want to take care of the variables first. So I'm going to take away the 2k from both sides, like that, and you get negative 1.5 on the right. You get 2k plus 2.5 on the left, and then you follow through with your decimals. Take away, like that. 2k is less than or equal to -4. Now we divide by a +2, which means the direction stays. It doesn't go anywhere. And we're going to get -2. And that's all we're doing there. So as you can see, the more of these you do, the more they look like equations almost. TSI. You have to learn to read the language. Twice a number, that means 2 times the number. Increase means to add. 6 is greater than. Is greater than means greater than 12. And so from here, I now have a statement, and all I have to do is subtract 6. 2n is greater than 6. Divide by 2. N is greater than 3. And the last one, it says if one ticket costs $10.50, how many tickets can one buy with at most $80? Now think about it. This is basically a division. How many of these can go into that? So I can say no more than $80 because that's all I can spend. And each one is $10.50 times a T for tickets. And then we can see 80 divided by 10.5 if you think about it. And all we have to do now is a simple division of 80 divided by 10.5, and I get about 7.619. Now remember, in the real world, you don't go up to a movie booth and say, I want 7.6 tickets. The best you can do is 7 with some change in your pocket. 7 tickets is the most you can purchase with $80. 7 tickets. And that's how it is. We have to read it carefully and translate it to real world terms. Once again, this was lesson 4.3.